So far we have discussed what is print statement, then how print statement will work. On the previous session, we discussed what is identifier and how identifier can be used in your project creation, the file creation, the variable creation, the function creation, and all the places. Okay? So today we will discuss one important topic. So this classes will go for another 1-2 weeks, guys. Okay, like 7 to 8 different sessions because we cannot complete data types in one single session. We go slowly because like data types are the very fundamental to the Python language. So if you know data types well, you can solve any Python problem. Most of the problems will be solved with the help of data types itself. Okay, so most of the interview questions will be asked only in the data types. Okay, so we'll go slowly. I will make you comfortable with the Python language, so don't worry, we'll go bit slow. Okay, don't think okay Srini, we almost completed 5 to 10 sessions, you still teaching data types, because data types very fundamental to the Python language. If you don't know data types, you cannot solve any big problem. Okay, so most of the problems will solve the data types concepts itself. Okay, so coming to the data types topic. Okay, so data type is a classification of data that specifies which type of value or a variable can hold, right? How it behaves and what operations can be performed on. So Python being a dynamically typed programming language, so it automatically determines the data type of a variable based on the value assigned to it. So here are the common data types available in Python. Okay. So you see integer type, float type, string type, boolean type, complex, none, list, tuple, dictionary, set, frozen set, and range. So these are the data types available in Python. Okay. So this is not the complete list. Python has few other data types as well. So whatever is important to the ETL testers have listed here. If you go to the like other data types in Python, right? You see byte array, octal, decimal. Okay, so we don't need those data types in our learning. So that's why I skipped it. But these are the fundamental data types that we will use in our day-to-day work, the ETL automation testing. Okay, once. Okay. Okay. Um, we'll discuss. Okay, so definition will come back after some time. Okay, so to make you comfortable with the SQL knowledge, right? So if you go to the SQL, so in the SQL we'll create the table. At the time of table creation, we use syntax called create table name, and then we start adding column name, right? Column name and then column data type and then column size, right? The same way in Python also. So if you want to create any variable or if you want to create any value, right? So it will automatically define some data type for it. Okay? So in SQL, suppose if you want to add some number values inside one column, we use number data type, right? Or integer data type. So depending on the database that we are using, we use number or uh, uh, integer data type. The same way, if you want to store the string related information into one single column, name column, for example. So we create name column as a string data type column. Okay. So if you want to store the number type, so we'll use again number. So phone number data. So we'll use number data. Same way in Python also, if you want to store any value, okay, we have to define data type. Okay, we have to define the data type. But in Python is a dynamically type programming language. We don't need to assign the data type explicitly. So Python internally understands, okay, so whatever values you are providing, it will take the value and then assigns the data type automatically. We don't need to manually pass the data type for it. Okay, so when it is assigned, it will assign one of these data types. Okay, integer, float, string, boolean, complex, none, list, tuple, dictionary, set, frozen set, or range. So additionally, we have byte array, octal. Okay, there are few other data types, but that we don't need. Okay, okay. So whatever is important, I kept those data types here. So now, so to make more segregations, right? So let me take a pen here. Okay. So Python has, so we can segregate this data, these all types into two categories. Okay, one, this part. Okay, this complete part. Okay, this is okay. This is fundamental data types. Fundamental data type. Okay, the below ones, right? So list, tuple, dictionary, set, frozen set, and range. Okay, these all we can say collection data types. Okay, collection data types. Okay, so first we'll slowly start with the fundamental data types, and then we jump into the collection data types. Okay, so first we'll discuss integer, float, string, boolean, complex, none. So once you are comfortable with all the information about these fundamental types, then we jump into list data type, tuple, dictionary, set, furniture, and range. Okay, so these are the data types. And you see byte, okay, so don't get confused. Byte array is there, okay, byte array, okay, but we don't need this, okay. Byte is one more type, okay, and then octal, okay, this is unnecessary for octal, decimal, okay. So these types are not required for us, so that's why I did not capture in this document, okay, but there are other types as well, okay. So now let me jump into the integer type, the practical example. So let me switch to Python. Okay. So for today's session, we create one more folder like this. Okay, let me create one folder. So on the daily basis, we create folders, guys. Okay. So yesterday session was day 4. So today's session will be day 5. Let me create one folder for today's session. So day 5. So today's date is 13/11/2025. Okay. So Python data types. Okay. We'll try to discuss integer and float today. If time permits, okay, I'll make it integer and float, or we'll just integer and float. So under this, let me get one Python file, that is module file. One second, guys. Okay, someone guide him, Amit, the chart. That's why yesterday I informed everyone, register here and then make comfortable with this portal. This is not rocket science, very simple website, right? Okay, that's fine. So once you created folder, yes, you can still hear me, right? Let's say yes or no in the chart. Use the chart. Clear, right? So far. Okay. So let me create one file under this. It's a Python file. Okay. So Python file. So Python into type. Okay. First data type in this case. Okay. So if you understand integer type, you will understand other data types easily, guys. Okay. Just focus. Don't write any code. Just listen to me. I'll explain step by step. So I'll create one variable A. Okay. Don't get be bored every time I'm using A, so we'll use some different name later. Okay, so let's take simple example, A equal to 10. Okay, so now let me use built-in function print. Okay, so I'll use value of A. Okay, value of A, okay, is A. Okay, we'll also use one more print statement, print. Okay, this time I'll use type. We do not type, right? We have to see the type of A is type of A. Okay, so next I'll write one more statement. Okay, id of a, okay, id of a, okay. So there is one more built-in function in Python, that is id. So what id will do, id will display the memory of, okay, memory of a variable, okay, memory location of a variable, okay, memory location of a variable. What type function will do, type function type function is a built-in function. Type function will display, okay, data type, okay, data type. So there is one more function, let me also display size, okay, size of a. You have to see the size also. Okay? Size of a. Let me put, okay, a dot size. This column is called size of. Okay? So there are two methods to display the size. So I'll go with the first option now. So maybe in the later part of the class, I'll introduce one more function. Okay? So now I'll run this code. Okay? To run the code, we have to right click on the editor window and then run python int. Okay? So if you observe the output here, right? So value of a is 10 because we defined a value as 10, a equal to 10. We are assigned this value 10 to a by using assignment operator equal. So equal is the assignment operator. Okay? And we are printing value of a is a. Okay? It is printing value of a is 10. The type of a is integer type. Okay? So we never specified, right, in this complete code, right, in the entire project, we never specified consider a as an integer type. But Python has dynamically typed programming language by default. Okay, based on the value that we assign here, it will be converted to the respective data type. So a 10 is the integer, so it created integer type here. Okay, so type is the function, built-in function, which actually displays data type of the variable. Okay, so it is an integer type. Okay, and id of a, you see id here, okay, 435090280. So this is the memory location of where a is available, where a is stored. Okay, where a is stored. Okay, and size of a, size is 28 bytes. The size is 28 bytes. Guys, clear? Okay, will display size. Just clear so far? Any questions? And there is one more method. Let me also introduce that method also. Okay. Methods available. Okay. Methods available. Or you can consider transformations in ETL perspective. Okay. Transformations. Okay. The function name is dir. Okay. Direct dir. Okay. So dir again built in. Okay. Whatever functions we are using, print, type, id. Okay. And then dir, all these are built-in functions in Python. We never imported anything, right? It's just directly we are typing and then we are using it. Okay? These are the built-in functions. Okay? These are built-in functions. Amit joined, still is struggling to find course. Amit.
He joined.
Oh. Okay. They should have tried yesterday. I'm sorry about it, but yeah. Okay? Anyway, we didn't discuss much. We just started. Okay? Amit, you can hear me, right? Amit, can you hear me? Yeah, I don't see him now. Yeah, I can see him. Okay, good. Okay. So we are discussing it. So, we have seen type, built-in function. These are the built-in functions available, guys, in Python. Okay. So type, ID, okay, dir. Okay, these are the built-in. Okay. We have seen type will display the data type of the variable a. ID will display the memory location of a, and size function will display. It is not built-in function. It is actually a method available in the uh, integer type. I'll discuss this size of in some time. Okay? And dir is one more method which it actually displays methods available or transformations available in integer type. Okay? Integer type. Let me put integer type and run the code again. Now you see methods available or transformations on integer type. Right? You see you can perform absolute. You know absolute, right? Absolute, what it does is it will convert negative number to positive number. Right? Add method, and method. So logical and logical or operation, right? Boolean type. Okay? Seal, and you see all these are starting with underscore. Okay? So these are actually, okay, these are actually special methods in Python. Okay? So if we found anywhere underscore, okay, some name underscore, okay, these are dunder methods in Python. Okay, double underscore dunder methods we say, or we can say these are special methods in Python. Okay, so dunder methods. So see this underscore abs is the dunder method. Underscore add is the dunder method. Underscore and is the dunder method. Likewise, there are so many dunder methods available in the integer type. Okay, see dir of a. So I passed a. A is the integer type, right? So you can also pass dir of 1. This still display the same output, same dunder methods as output. Okay. So on the integer type, what are the dunder methods available? What are the functions available or methods available or transformations available? Okay. So these are the available dunder methods. If you scroll slowly right, you'll find so many. Okay. Greater than, okay, hash, index, init. Okay. There are so many. Scroll all the way right. See, size of is one more. We are using size of, right? It's a dunder method. Okay. So what it does is, so on the A, there is a dunder method. By using this dunder method, we can discuss the size of your variable A. That's what we are doing. Okay. So underscore underscore is a dunder method on top of the integer type. We are calling that function by using this. Okay. Underscore underscore size of. If you scroll down all the way right, you'll find some methods which are not having an underscore underscore. As integer ratio, bit count, bit length, conjugate, denominator, right? And imaginary value, enumerator value, real value, and then 2 bytes value. So these are the normal transformation methods. Okay, you don't see much useful at this moment because integer type we don't do much transformations. But if it is a, but if it is a string type, we'll see some transformations which are useful to the ETL testers. Okay, so guys, clear so far? Any questions? So on these 5 lines of code, any questions? Yes, any questions? No. Can you chart? You guys can use chat option to respond. Okay, no question. So now I'll create one more variable A again. B I will create this time. Okay, B equal to 10. So the same lines of print statement, but wherever it is A, I will convert into B now. So, okay. Just listen now, don't write any line of code. I will use same value B equal to 10. So first I created A equal to 10. This time I'm creating B equal to 10. Okay. So I'll convert this wherever is A to B. B. So what is the type of B, guys? What is the type of B? Everyone respond in the chat. What is the type of B? Okay, integer type. Okay, good. Integer type. Okay. So let me put one print statement in between to segregate this outputs. Okay. Okay. So this print statement will actually multiply equal 100 times and then display one line between above lines of code and below lines of code. Okay. Now don't need to worry much at this moment. Just a simple print statement. This actually segregate the outputs by keeping equal symbols in between. Okay. Let me run. See. Okay. So these lines are coming from this single print statement. Okay. I wanted to segregate above print statement, below print statement to make it as two different blocks. Okay. So now if you observe the outputs here, okay. See, value of A is 10. It's class integer type. Okay. And then ID of A is 336. Size of A is 28 bytes. Methods available. These are the methods. Okay. So forget about these methods. Methods we'll discuss when once we jump into uh, string type. At this moment, there is not much useful. There is no much use for the ETL testers. These methods. Okay. So I'll slowly explain methods in other classes. Okay. So in the list, tuple, and then dictionary, we will use these methods much more in depth. Okay. But if you observe here, right? So value of A is 10, value of B is 10. Okay. You see here, ID of memory of A. Okay. Memory of A 431000836. Same value is assigned to ID of B also. So A and B is sharing same memory location. Yes. Observe. Please observe this. Okay. Same number 336 at the end, 336 at the end. That means A variable and B variable sharing same location. It's not two different locations. Okay. So let me explain how it works in the memory. So this topic is very important, guys. Okay. So first we created in the Python code. Let me draw one single Python file here. So we created one Python file, right? So consider this is .py file. Okay. And here we added. So we created some variables. In our code, we added variable A equal to 10 and B equal to 20. So these are two variables that we create. So B equal to 10. So what will happen in the internally, right? In the Python. Okay. So internally, what will happen? Okay. So in the memory, there are multiple locations. Okay. The multiple locations. Consider there are 4 blocks here. Okay. So the moment you add a equal to 10, okay, a equal to 10, so this a value will be stored here, right? Stored here as value 10. Okay, and these values will be empty, like this location, this location, and this location will be empty. Okay, so once a is assigned to some location, consider this location as, let me make, okay, this location as 1 2 3. So location as 1 2 3. Okay, so the next time, okay, this block of code is executed and memory is allocated. Okay, memory is 1 2 3. Okay, this memory is 1 2 3 here. Okay, and value is 10 here. So next time what will happen? You are running again one more line of code, that is b equal to 10. Okay, so what will happen? It will not create one more memory location. It will not go here, or it will not go here or here. Okay, first the task of the interpreter in Python, right? The task of interpreter in Python is, so it will check value 10 is already there in the memory or not. Okay, if it is already there, okay, so if it is already there, bus don't create any extra memory again. Okay, just simply go ahead and assign this b value directly to the memory which is already there here as 1 2 3. Okay, that's why same memory location is assigned to a and b in the Python code here. See, 336 336. Assume we came again and we added one more variable c equal to 10 again. So this time again it will check in the same memory, right? C is already present in the memory. We go ahead and assign same memory to the C also. Okay, C also will assign same memory location. Sorry. Okay, Python will assign, okay, for the C also same memory location as A. Okay, so A, B, C will share same memory location as 1 2 3. Now I came and added one more variable D. Okay, D equal to 15. So now it checks. Okay, now it checks in the memory D value is present in the memory or not. Okay, so okay, A value 10 is there, okay, 15 is not there. So what it does is, so this time, okay, this time, so it will go ahead and create one more memory here in this memory. So here it will store value 15 and assign value memory as 1 2 4 here. Okay, so D will get separate memory, A, B, C will have the same memory. So these three will share same memory. Okay, share same memory. Okay, same memory, but D will contain different memory location altogether because D value is different, but A, B, C values are same. Okay, one more guy came and added one more E value, E equal to 15 again. E equal to 15. This time again it will check in the memory, 10 is there, 15 is there. Okay, so this time E equal to 15. It will assign the same memory location again. So these two guys will have the same memory now. Same memory. Okay, one more guy came and added F equal to, okay, or maybe you only added F equal to 16 this time. Okay, 16 is not there. Okay, 10 15 is there in the memory, 16 is not there. So it will go and assign new memory location as 16 here. 16 may be 1 to 5, this one location. So 1 to 5 will be assigned to this F. Okay, assume E, then G equal to some number 17. Okay, so 15 is there, 16 is there, right? 10 is there, but not 17, right? 17 will be added to the one more memory here. Sorry. Okay, this 17, okay, this 17 will be added to new memory location here. Consider this is 1 to 6 memory and value is 70. Yes, understood how memory will be allocated in Python? Yes, clear? Interesting? Okay, now we'll switch back to Python. Okay, we have seen A, B. Let me add C also here. Right? So this time I'll make C. This B I'll update to C. So now tell me A, B, C will have same memory or different memory as per our understanding so far. Yes. Yeah. It will share same memory location. These two are not required. I'll remove this part. If it's unnecessary, we'll return. Okay. C. Okay. A, B, C will have the same memory location because A value is 10, B value is 10, and C value is also 10. Okay. So if I go back here, right, 128, 128, 128, same memory location for all three variables, A, B, C. Okay. Now I'll change. Okay. Now I'll change C value to 11. Now tell me which all variables are same memory and which are variable have different memory. So we have A as 10, B as 10, C as 11 now. How memory will be allocated now? So don't tell me the number. Number will vary every time we run the code. Just focus on whether it will be same or not. A and B will have the same memory, or A, B, C are same memory or not. Okay? This number will vary. Okay, every time we run the code, number will change. Okay, so I'll run the code now. Okay, observe this. A is 10, B is 10. Okay, and C is 11. Okay, so A, B will have the same memory location. C will have the different memory location. See, A is 432, B is also 432, but C is 11. It is 464. It's a different memory location. It will not share the same memory location. C will have the different now. Okay. So if I go to the Excel, right? So A, B, C as in our case, let me add one more. Right? So I'll make it quickly this time. So A equal to 10, right? B equal to 10, C equal to 11, right? So this is the code that you have written in .py file, right? So in the memory, so you get one block here. Okay, so it has multiple blocks. There might be so many blocks here, not just only four. I just written only four like this. You have multiple blocks. Okay, so when you create a variable, it will go to this block. So here it is 10. So B is also same value, same memory location, but C will go to the different memory location. So consider this is one location, this is two location, right? So two. So if I add C, maybe D equal to 11, C and D will share the same location too. Okay, guys, clear everyone so far? Clear, right? Clear. Okay. So now I'll create C equal to minus 11, or maybe D equal to minus 11. Now tell me C and D will have the same memory or different memory. So I will not use this type. We already know. Let me display the type also this time. Okay. So D. What is the type of D now, guys? What is the type of D? Type of D. It's minus 11. Still integer. Okay. Okay. C is 11. Okay. D is minus 11. C type is integer type. D type is integer type. Okay. So any number, okay, positive, negative, or zero, okay, it will still consider as an integer type only. Okay. You should not use any decimals. If you use decimals, it will convert to the float. So if you use a simple number, right, base 10 number, any number with base 10, so that number will be converted as a integer type. Okay, integer type. See, D is also integer type, but here 11 minus 11 has two different numbers. It will get two different memory locations, 552, 272. So two different numbers. It's not same numbers. Okay. So now let me add one more. Okay. So E. So I'll make E equal to 0 this time. So now tell me what is the type of E, guys? What is the type of E? Okay. It will be E type of E, guys. integer, float, zero, what is the type? Okay. So as I already discussed, 0 is also integer type. Okay. So value of e is 0 and type of e is integer type and type of e is, sorry, id of e is 792. Anyway, 0 is not there in the previous variable, so it will create new memory location for e now. Guys, clear everyone? Any questions? Any questions here? You can unmute and talk if you have any questions. Okay. Okay. So now we have seen, right, there are some dunder methods. So if you want to apply dunder methods on top of your VL list, right, you want to add two numbers. Okay. So we generally don't use underscore add. We use, suppose you want to add A and B, right? You can use directly A plus B. Okay. A plus B. Okay. A plus B. Uh, Otherwise, one more way is you can also use, okay, you can also use a dot underscore okay, add, okay, and then value under value. So print of a plus b, a dot add, both are exactly the same. Will give the same output. So let me show you. Let me put this between this and this. Okay, you see, a plus b output is 20. A dot underscore add of b is also 20. It is not different. It is same. Okay. So actually, right, to be honest, underscore add is overwrite of this plus. So it actually both are same, no difference. Okay, we'll discuss this part, what is underscore add, what is underscore r, and as part of the oops concept. But at this moment, this plus symbol, if you don't want to use plus, this is the other approach you can use. Okay. Any questions, guys, on this topic so far?
Yeah. Sri, I have one question.
Mm-hmm.
So in our programming, we use a plus b, or sometimes we use a dot underscore
We use
underscore
a plus b.
mainly. Yeah.
Yeah, we use a plus b.
Okay.
Yeah.
This is just for our knowledge purpose. This is
Yes, yes.
another
Yeah, another
another.
way. Yeah.
Okay.
Okay, clear? Yes, any questions so far? One more interesting thing, let me now show you. Okay, so I'll create uh, k as one variable, as 10. Okay, l as one more variable, 0. Okay, and sum I will use, okay, sum one variable, okay, equal to k plus l. Now tell me, what are the variables will have the same memory location? So we will print IDs of all three and see your understanding now. Okay. ID of k, ID of L, ID of some one variable. Okay. So K, L. Now tell me, what are the variables will have the same memory location? Someone. So what is the K value? 10, right? You're answering the chat. I don't see any answers. So out of these three variables, K, L, some one, what are the variables will have the same memory location? K and someone, okay. Okay, good, good. Let me run the code. If you observe, see, K as 328 at the end, someone is also 328 at the end. That means K someone will have the same value, right? So if I sum, if I add these two numbers K, like K and L, so K is 10, L is 0. So 10 plus 0 is 10 only. So again, it is same as your K value, right? That's why K and someone will share the same memory location. It will not be same. It will be same. Okay, sorry, it will be same. But L as value 0, so that's why it's a different memory location. So if you see my screen here, right, this is the output. ID of k is 328 at the end, ID of L is 3008 at the end, and some one variable ID is 328 at the end. So k some one has the same memory location because values are same. Guys, clear everyone? Any questions here?
Yeah, I have one. Actually, why we are using that print equals multiplied 100 every
So I
time?
wanted to separate the output of previous code, output of current code. That's why I'm using. So what this does is,
Oh, okay, okay.
so this
Yeah, got
multiply,
it, got it.
yeah, this multiply with the number 100 and then displays 100, 200 times equal. So if I use single equal, so equal will be repeated 100 times. This works as a repeat operation here.
Mm-hmm.
So I wanted to
Oh.
just segregate above output and below output. Otherwise, right? So if I remove it, it will be clumsy, the output.
Mm-hmm.
So we don't know what is
Got.
this 20, what is this 20. Just observe. See, it is coming here. So not if you want to use plus symbol, you can use plus also. Not necessarily equal. Now plus will be added. See, plus symbol. If you want to use hash, you can use hash. Or hash will come. So we got the equal. Okay. So if you are understood integer type, now we'll go to the one more data type called float data type. Okay. Let me use one more Python file. Python underscore float. Okay. Dot py is not read, directly control. Okay. So now again, okay, I will use a variable. And one more thing, what is the use case of this? When we can use in our ETL testing? ETL use case. We understood what is integer type and then what kind of value it can hold, right? Positive, negative, and zero value. And one more thing, maybe I forgot to discuss. So there is no range, guys. Suppose I have a variable called klmn. Let me create m. Okay? So m. So I have a big number. Okay? So this much big number. Let's see whether what type to assign to that m value. Let me take the code from here. Okay? Code from here, then add it here. Okay. So print of m, value of m. So in Java C language, you might have heard this, right? 2 power 32 to minus 2 power 32, some range, right? So Python doesn't have such concept. Okay. So whatever number it is, it will just see whether it is a base to 100 or not. Okay. So we'll main focus now. It will be a value and then type. Okay. ID is not required. Let it be ID also. Let me put this equal to separate it. Okay. See, value of m is this big number. I think more than 25 digits, right? And type, it is still integer type. It is not changed to some other type. Okay. So even if you can add like another the same numbers, right? It will still consider the integer type only. Guys, clear everyone? How it works? So there is no other data type other than integer in Python when it comes to the numbers. Okay, whole number. Okay, so and this is the ID of this is 408. And if you want the size, let me show you the size now. Okay. Size might vary. Now maybe in the beginning we have seen size is 28 bytes, right? So now let me show you the size also for this. What is the size of this big number? Okay, size of m. Okay, and run. So now this time size has increased to 72 bytes. Okay, because it's a big number, size has increased to 72 bytes. Earlier it is 20 bytes only. So 28 bytes, 28 bytes. Now it is 72 bytes because it's a big number, so it took some extra memory to store this big number. Yes, clear? Everyone clear? Respond in the chat, please.
Srini, number is always taking as an integer, right?
Yes, yeah.
Okay.
Okay. Yeah, if you are clear, the real use case of ETL, right? When we can use this integer type in your ETL testing? When we can use, guys? Consider you want to do the count check, right? So count check, always count will be number only, right? So it never be a float number, right? So count always some integer type, right? Integer, some number, right? So it cannot be 10.5, right? So it will be always integer type. So consider source count as one real use case of integer type in your ETL testing. Guys, clear? What else we can use, guys? What are the different use cases of this integer type in the ETL testing space? Don't tell me like transaction amount or number of people working in the company, all those things. Okay? Only in the ETL testing perspective.
Count column,
Count is done. The next part.
column count in a table.
Okay, number of columns. Yes, good. Number of columns. What else we can use, guys?
And data type, data length,
Some number. Okay, two column number of columns. Okay.
data length.
Length of column we can take, right?
Yes,
Length of any specific column, like 20 character, 40 character, or whatever, right? Length
yes.
of column. Okay. Length of phone, example, maybe 10-digit number. Yeah, difference. Okay. Source count, target count, difference. Okay. Source count. What else, guys?
Reconciliation.
What else? Mismatch count. Okay. Target count. Okay. Source count, target count. Okay. Number of column. Good. Data type wise count. Okay. Mismatch count. Yeah. So yeah, consider these are few use cases. If you want to list, you can list. Okay, for other things as well. But yeah, you can take any number. Like if you take any ETL testing, right? So we deal always with the numbers only, right? So validation perspective I'm talking about, not on the perspective of individual column data length or data size or whatever. Okay, so let me switch to float type. Uh, okay, so if you add any value with some decimals, okay, with suppose I've created variable a, right, with value as 10 dot. The moment you keep dot, so Python automatically, right, so Python is a dynamically type programming, is automatically convert this a value as a type as a float type. Okay, so let me show you. I'll just take the same code from here. Okay, because we already know. Okay, I'll just keep it. Okay, so if I use 10 just alone, so it creates as an integer type. We already seen this. Okay, so let me run this code. Okay, float type. So this is the code. This is the output. Value of a is 10. Its class is integer, and this is the memory location. This is the size of it, and this is the methods available in it. Now the moment I keep dot, right? So dot. Just observe the output now. See, it became float type. Okay, so it finds any decimals. Okay, dot, just alone dot is enough to convert it as integer to float type. Integer to float type. See, value of a is now 10.0. It is no longer 10 alone. 10.0. So type is float. It's not an integer anymore. It's a float type. So this is the ID of a. Okay, so 436 this at the rate 208. Size of a is 24 bytes. Okay, so integer it takes 28 bytes, but float will take lesser memory compared to the integer. Okay, depends on the size, guys. Again, okay, number of decimals. There are so many factors while deciding the size, but in this case, if I use a equal to 10, it was taking 28 bytes. Now a equal to 10.0, it is taking 24 bytes of the memory. Okay, 24 bytes of the memory. So now I'll take the same code again from here, B. Now you guys should tell me what is the, okay, what is the size of, okay, size, id, type. Okay, so this time here I use just 10 dot, here I'm using 10.0. Okay, so now tell me what is the value of b, what is the type of b, what is the id of b. So on, if it is id, like if you on once id of b is printed, whether it will be same as a or not. Okay, yeah guys, use chat box to comment. See, we have a is 10.0, b is a is 10 dot, I didn't keep any value here, and b is 10.0, right, 10.0. So now what is the type of b? First question, what is the id of b? Okay, so some number you can tell and tell me that number is same as the id of a or not. Okay, so just observe the output now. So let me put this line of code here and run the code again. Okay, value of a is 10.0, value of b is also 10.0. You write 10 dot or dot 0, both are same exactly. That we understood now by looking at this output. And then you see float type, both are float type. 752, 752. Memory locations are same. You see value of A is 10.0, value of B is also 10.0. Though you gave you 10 dot without any decimals, here 10.0, but still consider as 10.0. Okay. So now it is 10.0000. Now tell me A and B will have the same memory or different memory. And what is the value of A, value of B? Will be same or different? ID number same, okay? Same. Okay, let me run the code now. Okay, see. So you write 10.0. After this, you write 100 zeros. Okay, so it will not change. Okay, it will be same. So, but if I add 10.01, then memories will be different. See, 376, 120. Okay, so decimals, if it is all zeros like this, so many zeros, it will still consider as a 10.0 only. It will not change the value. It will be same. A and B will have the same memory location. But if I add 1 at the end, then memory will be different. See now. Sorry, maybe it is considering it as 0 only. I don't know. One second. Let me keep after how many we used. I think 14 it will accept. One second. 5. One second. Up to 14 it takes same. Let me make it with some less digits. Now it is different. You see, I think up to 14 zeros it considers as 0 only. If you add like lesser than 14 digits and then add some extra value after it, right? So like 1 like this, it will take the different memory location. Okay? So the reason I'm covering all this in detail, right? So we should know all this fundamental. We should be fundamentally strong in Python. So when you understand how data will be stored, what is the size of each value, right? What are the methods available in each data type? Right? Now, if you observe here, right, you see the similar methods also here. Same like your integer, but you'll find some different methods at the end. See, as integer ratio, conjugate, from hex, image, okay, is integer, is real. But uh, in the integer type, we'll see some different functions here. Okay, guys, clear? And now let me use one more. Let me take C. Okay, C. I will put here. Okay, so I will add C as 11.2 something. Okay, now A B. Let me put 10.00. A, B will have same memory location, C will have different memory location because it's altogether different value. Okay? Different value. C is float. It's a still float because it's 11.2 decimal value and memory is different. Yes, any questions? So far, any questions? clear today's topic? And how many of you already know this concept, guys? Memory concept and then type concept. I want to understand how many of you already know this concept before my explanation. How memories will be allocated, how data types will be allocated. Please respond in the chat, guys. Deepak, you don't know, okay? What about others? Okay. Okay, that's clear so far. If you are clear, we will stop it here today. And one more thing before we stop, right? Let me show you one thing. I'll create one string. Maybe this is trailer for tomorrow's session. So I'll make it as ETL automation. Okay. Okay. So we'll just focus on DAR. Okay. So this part alone. Okay. So tomorrow we'll discuss in detail about. Okay. So first we'll discuss string. Okay. And then we'll discuss. Okay. So DAR of str1. If I run this code, okay, if I scroll all the way right, you will see methods which are helpful for the ETL testers. You see, after render methods, we will ignore these methods. You see capitalize. Okay, we will see case fold, center, count, encode. Okay, ends with expand tab, find, format. Okay, there are so many methods. These can be used in your ETL testing. Okay, for both data quality checks as well as your transformation functions. So if you want to convert one string to another, like one format to another format, lower to uppercase format, or you want to convert lowercase to unit cap format. Okay, these are the functions we can make use of it. Okay, case fold is one, capitalize is one more function. Okay, count is one method where it will display how many times that any specific character is repeated. Okay, so tomorrow it will be more interesting session because from this topic we'll see a lot of questions in the interview. Okay, so don't miss the sessions, guys, because every session is important. Whatever topics we have chosen to teach in this training, this will be used in the framework sessions. Okay, if you miss sessions now, you will face difficulty in understanding frameworks.